Hello, future engineers, subscribers, viewers, and students. There is a video in Differential Calculus 2 about solutions to examples. And I think examples 1 and 2 are already in Differential Calculus 2 Part 1. But I have to solve these problems again for your mastery also. So first, we have find the first derivative of the following functions. Y is log of square root of quantity 2x plus 5. So remember the derivative with respect to x of log of u, where u is the square root of 2x plus 5 is 1 over u log to the base b of e, then derivative of u with respect to x. So imagine that square root of 2x plus 5 is the u. So derivative of y with respect to x is 1 over square root of 2x plus 5 log of, because that's log to the base 10 understood, of e. Then the derivative of square root of 2x plus 5 is derivative inside 2 divided by 2 square root of u. You just copy. So the guide is derivative of square root of u is du dx in the numerator, in the denominator 2 square root of u. Or you may apply power formula. Cancel out 2. So the final answer is dy dx is log of e divided by 2x plus 5. Letter B, log of sine square of 4x. Imagine that sine square of 4x is u. So dy dx is 1 over sine square of 4x log of e, then the derivative of sine square 4x, which is the u. So power formula 2 times sine to the 1 of 4x. Derivative of sine is cosine of 4x. Then finally, derivative of 4x, which is 4. So simplifying and cancel 1 sine 4x. So this is 2 times 4, 8. Then log of e. In the numerator is cosine 4x left. In the denominator, sine 4x. And cosine 4x over sine 4x is cotangent of 4x. Letter C, ln of quantity x y square equals xy. So derivative of ln of u is 1 over u du dx. Imagine that xy square is u. So derivative is 1 over u, 1 over xy square. Then the derivative of xy square, which is first x, derivative of y square 2y dy dx, plus second y square, derivative of x 1. Then equals derivative of the right side, product again. So first x, derivative of y dy dx, plus y, derivative of x 1. Simplifying, this is cancel out x, cancel y. So 2 over y dy dx, then cancel y square plus 1 over x, distribute, then equals x dy dx plus y. Combining dy dx and transposing y to the left, so we have 1 over x minus y equals dy dx times quantity x minus 2 over y. Simplifying, we have 1 minus xy over x, then dy dx times xy minus 2 over y. Then finally, cross multiply y times quantity 1 minus xy equals x times quantity xy minus 2 dy dx. So dy dx is y, quantity 1 minus xy, all over x, quantity xy minus 2. So that's for examples 1. Example 2, find the first derivative of the following functions. So we have exponential functions. Y is 5 to the 3x. Letter B, y equals e to the cosine 2x. Letter C, e to the ln 4x plus e to the ln 4y equals 1. So we use identities here to simplify the derivatives. So for exponential function, this is the guide. Derivative of a to the u is a to the u ln of a du dx. So you just look at the derivation of the formula for exponential functions. So therefore u is 3x and a is 5. So dy dx is a to the u, so 5 to the 3x ln of a, ln of 5 times derivative of 3x, which is 3. Simplifying, that's 5 uh, to the 3x, then ln of, because this is 3 ln of 5, ln of 5 times 3 is 3 ln of 5, and we can write that as ln of 5 cube by property. So ln of 5 cube is the same as ln of 125. Therefore, derivative of y with respect to x is 5 to the 3x ln of 125. By the way, for these functions, log, this one, you can use your calculator to check these answers. You just assign values of x that make it defined. Except for letter C, it is an implicit function. You cannot do that. So you have to perform the basic differentiation process. So that's it for A. For B, y equals e to the cosine 2x. It's like y equals e to the u. The derivative is e to the u du dx. E to the u du dx, the guide. So dy dx u is cosine 2x. So e to the cosine 2x times derivative of cosine 2x, which is negative sine 2x, then derivative of 2x, which is 2. Simplifying, dy dx is negative 2 sine 2x e to the cosine 2x. Then number 3, e to the ln 4x plus e to the ln 4y equals 1. E to the ln of something is something, just like e to the ln x just as x. So e to the ln 4x is 4x. E to the ln 4y is 4y, then equals 1. You can also perform this differentiation using this guide if you want, and it will arrive at the same answer, but that would be a longer process, and we use identities for that case also. So 4x plus 4y equals 1, differentiating 4 plus 4y prime or dy dx equals derivative of 1, 0. So dy dx is negative 4 over 4, and that's negative 1. So for this example 3, find the first derivative of the following functions. So these are um, variable raised to variable. So our guide y equals u to the v. Then we have to perform what we call logarithmic differentiation. So ln y is ln of u to the v, and the rest would be definition of ln of u to the v and differentiation. So for the first example, we have to take ln both sides. So ln y is equal to ln of x to the ln of x. By the way, the given is y equals x to the ln x. That's the original given. So y equals x to the ln x. So taking ln on both sides, so ln of y equals ln of x to the ln x. Differentiating ln derivative of ln of y, and we can rewrite this as ln x times ln x by property of logarithms. Then we can make it as one combined ln of x quantity square. So differentiating the left side, dy dx over y equals 2 power formula ln of x, then the derivative of ln of x is 1 over x. So dy dx is equal to y, and y is x to the ln x, then times the quantity 2 ln x over x. So combining, dy dx is 2 ln x, then let's combine x to the ln x minus 1 because we have over x here. So that's it for that first problem. Second, y equals x to the e to the x, taking ln both sides, ln of y equals ln of x to the e to the x. We can write this as e to the x ln x. So differentiating 1 over y dy dx equals derivative of product e to the x times derivative of ln x 1 over x plus second ln x, derivative of e to the x is just e to the x. So dy dx is equal to y, and y is x to the e to the x, then quantity e to the x over x, or e to the x, factor out e to the x, times quantity 1 over x plus ln x. Simplifying further, then we have x to the e to the x times quantity e to the x times quantity 1 plus x ln x all over x. So finally, dy dx is combining this, bringing x to the numerator. So we have x e to the x minus 1, then times e to the x, quantity 1 plus x ln x. So that's it. By the way, you can use your calculator if you want to check these answers. You can assign a value of x that will make it defined. So you can assign x equals any value as long as it is defined. Then letter C, y equals x to the x squared, taking ln both sides. Ln y equals ln of x to the x squared. We can write the right side as x squared ln x. So differentiating ln of y is derivative is dy dx over y. Then derivative of product x squared, derivative of ln x is 1 over x, plus second ln x, derivative of x squared 2x. Then cross multiply dy dx is y, which is x to the x squared, times quantity, this is x, plus 2x ln x. Finally, factor out x and combine the power with x to the x squared. That becomes x to the x squared plus 1, then quantity 1 plus 2 ln x. That's it for example 3. Example 4, this is about hyperbolic functions. This is our guide. Derivative of tangent hyperbolic of u is secant hyperbolic square of u du dx. You look at the derivation and the mnemonic aid on how to memorize derivative of hyperbolic functions and even inverse hyperbolic functions. So imagine that 4x plus 1 is the u, 1/5 is the constant, that's no problem. So dy dx is constant, 1/5. Derivative of tangent hyperbolic u is secant hyperbolic square of u, which is 4x plus 1, times the derivative of u, or derivative of 4x plus 1 with respect to x, which is 4. Simplifying, we have 4/5 secant hyperbolic square of 4x plus 1. Number 5, y equals secant hyperbolic square of 4x. The guide's derivative of secant hyperbolic of u is negative secant hyperbolic u tangent hyperbolic of u. But first, we apply power formula. So dy dx is power 2, quantity secant hyperbolic to the 1 of 4x. Derivative of secant hyperbolic of 4x, or u, is negative secant hyperbolic 4x tangent hyperbolic 4x. Then finally, derivative of 4x, which is 4. Simplifying, that's negative 8 tangent hyperbolic 4x, then secant, so secant hyperbolic square of 4x. Number 5, y is, uh, that's the problem statement in 4. Then problem 5, what are the equations of the tangents to the curve y equals x cubed minus 7x plus 6 at its point of intersection with the x-axis? So if there is a curve and the curve intersects the x-axis, note that the y value there is 0. So the value of y is 0. So equating first y is 0 to find the points where the curve, this cubic, crosses the x-axis. So 0 equals x cubed minus 7x plus 6. Uh, Without the calculator, you have to apply to trial and error by uh, synthetic division, but you have your calculator there. In fact, it can uh, find roots even for quartic functions. This is just cubic. So the roots are x is negative 3, x is 2, and x is 1. So derivative y prime, or slope, is 3x squared minus 7. And the slope when x is negative 3 is 3 times negative 3 quantity square minus 7, and that is negative 27 minus 7, so it's 20. So if the point of intersection gives x is 2, y prime when the slope is 2 is equal to 3 times 2 square minus 7, and that's 12 minus 7 or 5. Then finally, for the third point of intersection with the x-axis, the slope y prime at 1 is 3 times 1 square minus 7, and that's negative 4. For the slope 20, the equation of the line would be 20x minus y. That's the guy. Slope of the line is negative coefficient of x divided by coefficient of y. So that's positive 20, negative 20 over negative 1. That's positive 20. 20x minus y equals 20 x1 minus y1, where x1 is negative 3 and automatic y1 is, or yt is 0 because we have points of intersection with the x-axis. Y is 0. So the first tangent is 20x minus y equals negative 60. For the second, the slope is 5. The equation is 5x minus y equals 5 times 2 minus 0, and that is 5x minus y equals 10. For the third, the slope is negative 4, 4x plus y, that's the equation guide, equals 4 times 1 plus 0. 4x1 plus y1. So 4 times 1 plus 0. So 4x plus y equals 4. Sample 6. Find the equation of the tangent and normal line to the curve y equals 3x squared minus 2x at 1, comma 1. So when x is 1, 3 times 1 squared 3 minus 2 times 1, 1. So y is indeed 1 because there are problems made by some who are not ensuring that the point is a point on the curve. So these are points on the curve. So this is a point on the curve. So derivative of y with respect to x is slope 6x minus 2, and we substitute the value of x, which is 1. Slope therefore is 6 times 1 minus 2, so 4. And the equation of the tangent would be in the form 4x minus y, that's slope line with slope 4, equals 4 times x1, which is 1, minus y1, which is also 1. So 4x minus y equals 3, that's the tangent. For the normal, we just interchange coefficients and change the sign. So x plus 4y, the slope of the normal is negative 1/4, negative reciprocal of that. So this is a line of slope negative 1/4, equals x1 1 plus 4y1, 4 times 1. So x plus 4y equals 5. That's the normal. Example 7, find the equation of the tangent to the parabola y squared equals 6x minus 3 perpendicular to the line x plus 3y equals 7. So differentiating 2y, y prime equals 6. So that means y prime equals 3 over y. The slope of this line is negative coefficient of x divided by coefficient of y. So negative 1/3. Therefore, the slope of the tangent line, because the tangent line is perpendicular to this line, is the negative reciprocal of negative 1/3, which is positive 3. And therefore, the value of y prime is 3, so 3 equals 3 over y sub t is 1. Then substitute into the original equation of the parabola to solve for xt. So 1 square equals 6 times xt minus 3, so 4 over 6, x sub t is 2/3. The equation of the tangent therefore is, because the slope is 3, 3x minus y equals 3 times xt minus yt, which is 1. So 2 minus 1 is 1. Therefore, it is 3x minus y equals 1. Example 8. This is an implicit function. Find the equation of the tangent to the ellipse x squared minus xy plus 2y squared minus 4x plus 2y plus 2 equals 0, parallel to the line x minus 4y equals 2. So this is an ellipse because there is an xy term. Its axis is rotated. It may look like that or like that. So differentiating 2x minus, we have product quantity first x derivative of y prime plus second y derivative of x 1 enclosed derivative of 2y squared 4y prime minus 4 derivative of 2y prime derivative of 2 0 equals 0. So expanding 2x minus xy prime minus y plus 4y prime minus 4 plus 2y prime equals 0. So y prime is equal to slope of this line also because the tangent is parallel to this line. The slope of this line is negative 1 over negative 4 and that's positive 1/4. Substitute 1/4 for y prime here to solve for the or to relate the variables. 2x minus x times 1/4 minus y plus 4y times 1/4 minus 4 plus 2 times 1/4 equals 0. So we have negative y and positive y. You can cancel that out. And 2x minus 1/4 of x is 7/4 of x. And we have uh, negative 4 plus 1/2, this 1/2 is negative 7/2 equals 0. Therefore, x is 2. X is x sub t equals 2, the point of tangency. Then substitute into the original equation to solve for yt. 2 times uh, 2 times 2 or 2 square minus 2 y sub t plus 2 y sub t square minus 4 times 2 plus 2 times y sub t plus 2 equals 0. We can cancel negative 2yt and 2yt, leaving 2yt square. Then the constant is 4 plus 2, 6 minus 8 minus 2 equals 0. So y sub t is y sub t square is 1, therefore y sub t is plus minus 1. So we have 2 points of tangency because that's an ellipse and it's parallel to that line. So obviously there are 2 points of tangency. One is x sub t is 2, y is positive, yt is 1. So the equation of the tangent, because the slope is 1/4, is x minus 4y equals xt minus 4yt. So x minus 4y equals negative 2. That's the first tangent. At 2 comma negative 1, x minus 4y equals 2 minus 4 times negative 1. So x minus 4y equals 6. That's the second tangent. Example 9. Find the rate of change of y with respect to x at the point 3, 2 if 7y squared minus xy cubed equals 4. So this is just differentiating with respect to x, and the rate of change of y with respect to x is dy dx or y prime. So first, we have 14y y prime, then derivative of product, so minus quantity first x, derivative of 3 of y cubed 3y squared y prime plus second y cubed derivative of x1 equals derivative of 4 0. Substitute the value y and x here. So 14 times y2 y prime minus quantity x is 3 times 3 y squared 2 square y prime plus 2 cube equals 0. Then simplifying 28 y prime minus 9 times 4 36. For 28y prime minus 36y prime is negative 8y prime. And for the constant, negative of 2 cube or negative of 8 equals 0. So y prime is negative 1. That's the rate of change of y with respect to x. Example 10. Make the cubic y equals ax cubed plus bx squared plus cx plus the b tangent to the line y equals 12x plus 13 at the point negative 1, 1 and have a horizontal line at the point 1, 5. There are 5 unknowns here. We evaluate A, B, C, and D. Let us check if there are also 4 conditions. So this is the point of tangency at negative 1, 1. This is a point on the curve. So that's one condition. And it is tangent to this line. The slope of this line is 12. That's the second condition. And has horizontal tangent line, meaning the slope is 0 at the point 1 comma 5. So another point on the curve 1 comma 5, that's the fourth condition, and tangent horizontal or 0 y prime, that's the third condition. So this problem can be solved. So this is the original equation. The derivative y prime equals 3ax squared plus 2bx plus c. So at the point negative 1 comma 1, so 1 equals a negative 1 cube plus b negative 1 square plus c negative 1 plus d. Transposing all the right terms to the left and the left term to the right. So a minus b plus c minus d equals negative 1. Call that equation 1. Then at the point uh, y prime, the slope is 12. At the point negative 1 comma 1, so 3a negative 1 square plus 2b negative 1 plus c. Simplifying, that's 3a minus 2b plus c equals 12. Call that equation 2. Then again at 1 comma 5, another point on the curve, y is 5, so 5 equals a 1 cube plus b 1 square plus c times 1 plus d. Simplifying, that's a plus b plus c plus d equals 5. Call that equation 3. And finally, the slope is 0 at 1 comma 5. 0 equals 3a 1 square plus 2b times 1 plus c. Simplifying, that's 3a plus 2b plus c equals 0. Equation 4. Actually, with your calculator capable of solving 4 simultaneous equations, you can solve right away a, b, c, and d. But I have only a calculator capable of solving 3 simultaneous equations, so I need to solve this using elementary algebraic process. So first, I add equations 1 and equations 3 to eliminate b and d. So a plus a, 2a, c plus c, 2c, negative 1 plus 5, 4. Simplifying, a plus c equals 2. Then we have to subtract equation. We have equation 4 subtracted from equation 2 to eliminate uh, a and c. We can now solve for b. So 3a minus 3a 0, c minus c 0, negative 2b minus 2b, negative 4b, and 12 minus 0 is 12. From there, b is negative 3. We then substitute negative 3 into equation 4, 3a plus 2 times negative 3 plus c equals 0. So 3a plus c equals 6. Then together with this equation here, a plus c equals 2. Let's subtract to eliminate c. 3a minus a, 2a. 6 minus 2 is 4. So a is 2. We then substitute the value of a is 2 into this equation. 2 plus c equals 2. So c is 0. Then finally, into this equation here, equation 3, the values of a, b, and c to solve for d. A is 2, B is negative 3, C is 0, plus D equals 5. So D is 5 plus 3, 8 minus 2, D is 6. Therefore, the cubic is y equals a 2 x cubed plus b negative 3 x squared plus c 0. So there's no x term plus d, which is 6. So that's it for that problem. So example 11. The radius of a sphere, initially 0, increases at the rate of 4 millimeters per second. Find how fast is the volume increasing at t equals 2 seconds. So we're looking for the rate of change of the volume with respect to time, because this is time rate of change, how fast increasing at the rate of 2 at the rate at volume increasing when t is 2 seconds. So given rate of change of radius with respect to time 4 mm per second, and it is constant beginning with 0 value. So it's like this is the speed and the rate of change of radius 4 mm per second. The volume of sphere is 4/3 pi r cubed. So the derivative of volume with respect to time is equal to 4/3 pi times 3r squared dr dt. And 4/3 pi times 3r squared dr dt can be simplified into 4 pi r squared dr dt. So r is beginning with 0 plus, this is the rate 4 mm per second, times 2 seconds. So after 2 seconds, the radius becomes 8 mm, and substitute into this equation, dV/dt is 4 pi times 8 squared times 4 mm per second. Mm squared times mm per second is cubic millimeters per second. So the rate of change of volume with respect to time, 1024 pi cubic mm per second. Then lastly, example 12, the dimensions of a box are x, x plus 1, x plus 4. Find how fast, letter A, the total surface area A increases as x increases, and B, the volume increases as x increases. So this is the box. These are the dimensions x, x plus 1, and x plus 4. You can interchange if you want, but the area and the volume remain the same. So this is the total surface area, 2 times the front area because the rear area is also the same, 2 times quantity x plus 4 times x plus 1, then plus 2 times top and bottom area, 2 times x, then this dimension x plus 4, then finally 2 times right and left surfaces, so 2 times x plus 1. Expanding, so area S is 2, quantity x squared plus x plus 4, 5x, then 4 times 1, 4. This is 2x squared plus 8x, then plus 2x squared plus 2x. Combining like terms, 2x squared plus 2x squared plus 2x squared is 6x squared. 2 times 5x, 10x, plus 8x, so 18x plus 2x, 20x, and the only constant is 2 times 4 or 8. We are now ready to differentiate this with respect to x. Derivative of area S with respect to x is 12x plus 20. So the answer, rate of change of area as x increases with respect to x is quantity 12x plus 20 square units per unit. Then for volume, volume is length times width times height. You just multiply all these dimensions. X plus 4, x plus 1 times x. Since x plus 4, x plus 5 is this expansion here, x squared plus 5, x plus 4, then we just multiply it by x. So volume becomes x cubed plus 5x squared plus 4x. Differentiating dv dx is 3x squared plus 10x plus 4. So the answer, the derivative of volume with respect to x, or the rate of change of volume with respect to x, is quantity 3x squared plus 10x plus 4 cubic units per unit. So that's it for this video.